You're told to write an equation of a line containing the given point and parallel to the given line. Okay. What that means. You're given a line. Here it is right here. And I'm going to write it right here in step 1. Now I am. That's called the given line, because they give it to you. There's also a given point. I'm going to write that down here. That point, 9, -1. Okay. This is called the given point. There, PT, point. Now here's what they're asking. They're saying find, and I'll probably erase this, but they're saying find the equation of a line. So find the equation of another line. So I'm actually going to write the point slope formula. Y minus Y1 equals M times X minus X1. And actually, we can go so far as to put the given point in here. Y minus -1 equals, we don't know what the slope is yet, so I'm just going to say M X minus 9. Okay, now a note. This line is parallel to I'm going to turn this off. Turn power off. Now hopefully it stays off. I hate my phone. All right, this line is parallel to the given line. Well, the given line is 8x minus 7y equals 4. Okay, and I'm going to hazard a guess without knowing for sure that generally speaking, 8x minus 7y equals 4 looks something like that. It's a straight line. And I believe the slope is positive, so it's going to be rising from left to right. A line parallel to this line is going to look like this. It's either under it or over it. And I can't make parallel lines very well, obviously, but these guys aren't tilted like this, but they have exactly the same slope. So let me erase this and try one more time. And I'm going to cheat by using my favorite cheat. Right here. Try to make that as close to parallel. Make all these close to parallel. Okay, so let's see our blue line. Well, I didn't do it, did I? Try it again. There. It's not perfect, but I, alas, am not perfect. There now. These are supposed to be going side by side forever, and they never cross because they have exactly the same slope. And the reason I made this line and this line is that I don't know whether the line we come up with, this line, I don't know if it would be above or below. So anyway, we are going to find the equation of the line that goes through the given point, and it's parallel to the line we're given. The first step is always to use the given line to find the slope. Well, that's what I'm going to do now. I might as well do it here. I'm going to subtract 8x from both sides of this equation. 8x minus 8x is 0. So we're left with negative 7y. And because I'm working with a straight line, I'm going to write 8x plus 4, negative 8x plus 4. I know that's positive because there's not a negative sign in front of it. All right, now to solve for y, I'll divide by 7 and divide by 7 and divide by 7. Boom, boom. And what I have is y equals, well, I don't even have to go to that much trouble. Now that I have solved for y, I know that this is the slope. And I don't really care about that at all. This is the slope. So I'm going to say m equals negative 8 over negative 7, just the number part. Well, the negatives cancel, leaving me with 8 over 7. And now I know what the slope is. So I can come down here to where I find the equation of the line. Step 2. There are only 2 steps when you're finding the equation of a line parallel to another line. And now I can write this, y plus 1, negative negative is plus, equals 8/7 times x minus 9. So since I've slept since last week, let me rewrite this the way I need to. The way we get rid of a fraction is to multiply both sides of the equation by the denominator of the fraction. Okay, the reason I wrote that as 7 over 1 is because I'm going to multiply it by 8/7, which is a fraction. Just makes life easier. The 7 up there cancels the 7 down there. And now I just don't have to deal with fractions for a while. Okay, now I'm going to distribute. Okay. All right, 7y plus 7 equals 8x minus 72, because positive 8 times negative 9 is negative 72. Now, I solve for the 7y term, so I will subtract 7 from both sides of the equation. Seven minus 7 is 0. I'm left with 7y on the left equals 8x minus 72, and then minus another 7 is minus 79. Then I'll solve for y by dividing by 7, dividing by 7, dividing by 7. On the left, the 7's cancel, which is the whole reason for doing it. And over here, the equation of the line parallel to the given line that goes through the given point. The equation of the line that goes through the given point that is parallel to the given line is 8/7 x minus 79 over 7. Ta-da! So, notice. It says write an equation of the line containing the given point and parallel to the given line, where this is the given line. The first thing you do is use the given line to find the slope of the given line. Then you use the point slope formula to calculate the line parallel to the given line. And it goes through that given point, so I automatically know what x1 and y1 are. Questions about what I did? Okay. Now we're going on to perpendicular, and that's a little more difficult. There are 3 steps. You do have a given line, and you do have a given point. But let me, there, this needs to be bigger. There. Okay, 5x plus y equals 8 is going to look like that, basically. And a line perpendicular to that line is going to cross that line at a right angle. And it's going to go through the point, wherever it is on that line, 2, 4. So the line I made blue is the given line. This is the line we're going to find. And when I say that, I mean find the equation of. dot, dot, dot. So on and so forth. All right, so let's do this. Step one, again, is to use the given line to find the slope of the given line. Well, this is going to be pretty easy. All we have to do is subtract 5x. Now I should have, well, don't be picky, Barbara. So I'll have y equals negative 5x plus 8, and I can see immediately that the slope of the given line is negative 5. So the slope of 5x plus y equals 8 is negative 5. All right, now we need to find the slope of the perpendicular line. There's an A and a B for that. Actually, there's an A and a B and a C, I think. We'll see. A is write the slope of the given line. Write the slope in step one, that's better. Write the slope in step one as a fraction if it's not already a fraction. Okay, so the slope of the given line is negative 5. Negative 5 is not a fraction, but I can always write it as a fraction. Just by doing this. Negative 5 divided by 1 is negative 5. They're exactly the same number, but they're expressed differently. Okay. Now, that brings us to step B. Write the reciprocal. Now, those of you who know how to do this, don't jump. There's a step C. Write the reciprocal of the fraction in step A. Well, the reciprocal is the flip. So that's going to be 1 over negative 5. Let me put a colon there. The reciprocal of the fraction in A is 1 over negative 5. Now here's step C. Change the sign. Of the fraction in step B. Okay, well, the fraction in step B, right here, is 1 over -5. If I'm going to change the sign, well, let's see, 1 over -5 is -1/5. If I'm going to change the sign, the negative will become positive. So the slope of a line perpendicular to the given line is +1/5. And now, once I look up here to find the given line, 2, 4. I can write the formula for the point slope formula. And I can write the whole thing. Y minus 4 equals 1/5 times x minus 2. That was the hard part, where you have to be oh so careful is in step 1 and especially in step 2. First, you write the slope of the given line that you just found in step 1. Then you take the reciprocal of it, then you change the sign. So there's an ABC approach to step 2. Okay. So now find the equation of the line perpendicular to the given line. We are ready. We are ready. We don't have to do anything different now. We are just going to find the equation of this line. We're going to work this out. Okay. So the denominator is 5. I multiply both sides of the equation by 5. And that 1 there goes with the y. It's kind of a problem. So I'm going to write it smaller. There. Okay, now I'm going to distribute and I'm going to cancel. And I really wish I would have waited. But what is that going to leave me with? 1 over 1, which is 1. So I've got 1 times x minus 2. Perfect. So I will have 5y minus 20 equals 1 times x minus 2 is x minus 2. And now I'm ready to move along. I will add 20 to both sides of the equation. -20 plus 20 is 0, leaving me with 5y on the left. Copy the equal sign. X minus 2 plus 20 is plus 18. And that's where I am right now. Now I am going to be dividing each term by 5. This necessitates that I acknowledge that there's a visible number in front of the x, 1. There's always an understood 1 when you have a variable standing by itself. So I will divide by 5, divide by 5, divide by 5. So my answer is going to be y equals 1/5 x plus 18/5. That's the equation of the line. This line right here, that's perpendicular to this line. And the line we just found goes through the point 2, 4. Now let's do it again. All right, we've got 3 steps, and we're looking for a perpendicular line. Okay, the first thing we do is we find the slope of the given line. 5x plus 4y equals positive 9. It's really easier to do it that way. Then I'm going to subtract 5x from both sides of the equation. Didn't have to do that. I'm trying to train myself to not always add and subtract vertically. All right. There. 5x minus 5x is 0. So I'm left with 4y equals negative 5x plus 9. Then I divide by 4, and I divide by 4, and I divide by 4, although we don't really care about 9/4. What we're looking for is the slope. Okay, the slope of the given line is negative 5/4. Now, if you already know how to find the opposite reciprocal, which is what it's called, what I'm about to do, finding the slope of the perpendicular line, you certainly don't have to go through steps A, B, and C. But if you don't know how to do it, it's a good idea to break down what you're going to do now as A, B, and C. A, write the slope of the given line. B, write the reciprocal. C, change the sign. That's the slope of the perpendicular line. The line perpendicular to the given line. So again, I look 0, 8, okay. This new line that we're finding goes through the point 0, 8. So I write y minus y1 equals m times x minus x1. So y minus 8 equals m, which is 4/5, times x minus 0. So let's rewrite it. y minus 8 equals 4/5 x. Because of that 0. What is x minus 0? It's x. So I will add 8 to both sides and I'm done. And this problem is a lot faster. So we'll have y equals 4/5 x plus 8. This line is perpendicular to that line right there. Let's see if we have another one. No, we don't. So let's look at parallel lines. Parallel lines have the same slope. That's what makes them so much easier. All right, parallel lines. Well, parallel lines. Have the same or equal slopes. That's why this process is faster. You find the slope of the given line and you just use that in your point slope formula. There's no worries about reciprocals or anything else. You just set up your point slope formula like you always would. And if you don't remember it, here it is. I always write it first because that helps me put numbers in the right place. Perpendicular lines, on the other hand, are a little more difficult. Okay? Only because you have to think more. Think more. When you see the word perpendicular, you are probably going to have to find opposite reciprocal slopes. Perpendicular lines. Have what's called opposite, meaning opposite sign, reciprocal, slopes. And the almost foolproof way to do this is after you find the slope of the given line, you take an A, B, C approach. You write the slope in step 1, the slope of the given line. You find its reciprocal, and then you change the sign. Then you use it in the point slope formula. Notice you're already given a point. This line we're finding goes through that point. So x1 is 2 and y1 is 4. Then to get rid of the fraction, you multiply both sides of the equation by the denominator of the fraction, and that just makes it easier. Most people have trouble with fractions. If you don't, then just go ahead and distribute 1/5. If you feel comfortable with fractions. Okay, discussion. Discussion, discussion, discussion. Parallel, perpendicular. Get your flashcards out and write this down, although it will be in Module 2, because this is week 2. All the notes and videos for Module 1 are in Module 1 in Canvas. The videos and notes for week 2 will be in Module 2. This is what a piecewise-defined function is. You have a line like x plus 8. Going like that, and then it stops. In fact, this line, let me remember to use my lines. They are straighter. There. Now, if we let this be black, and we let this be, actually it's called deep violet, that. Then what this says is that at x equals 2, these guys change, and you have a different function over here. So that this is y equals x plus 8. And then at x equals 2 on the x-axis, x plus 8 stops, and 7y equals, let's erase that. Y equals 7 minus x starts and goes on forever. That's what a piecewise-defined function is. And you had, when we studied domain, that is reviewed domain, we had this graph. It was red. And it kind of looked like this, and this, and this. That's a piecewise-defined function. All right, where this has one equation, this has a different equation, and this has a different equation. So that's what we're working at here, with here. But right now, all we're doing is we are evaluating functions. Okay? Here's what this says. G of x equals x plus 8 for all the x's on the number line that are equal to or less than or equal to or to the left of 2. Less and left are the same thing. On the other hand, on the right side of 2, you've got y equals 7 minus x. And so where these two functions change, it's the same function, but different parts. Where part 1 and part 2 change is at x equals 2 on the x-axis. So this is the x-axis. This is the x-axis. And you go out to infinity here, and you go out to negative infinity here. And we have to decide, well, where the heck is x equals 2? Let's let it be here. Then what do we have? We have 1 and 0 and negative 1 and negative 2 and negative 3 and negative 4 and so on. And 1, 2, 3, 4, 5, 6, and so on. But this is where your change happens right here. I'm going to make a little dashed line. Okay. Now I'm not being asked to graph anything, so you don't have to panic. This is what this comes down to over here. Over on the left side of 2 and including 2, we have y equals x plus 8. And this includes 2. Now over on the right side of x equals 2, we have y equals, let me call it g of x because that's what it is. G of x. But g of x is just y. Okay, and g of x equals 7 minus x. These are the two parts of g of x, and it all depends on where they're located with respect to the number 2 on the x-axis. So now, here's what we're being asked to find. We're being asked to find g of -3, g of 2, and g of 6. Make sure that's right. Yeah, okay. So, -3 is over here on the left of 2. So to find g of -3, we have to use this function right here. Okay. Now, g of 2. Here's where x is allowed to equal to, right here at x plus 8. So our 2 is also going to use this side, the left side. So g of 2 equals 2 plus 8 equals 10. So let me write these down, 5 and 10. And now g of 6, 6 is located to the right of 2, so we're going to use this side. G of x equals 7 minus x equals 6 equals 1. So g of 6 equals 1. And that's all there is to it. Gladly. So in words, what this says is, to the left of 2, or for x equals 2, use g of x equals x plus 8. to the right of 2, and you can see the arrow pointing to the right here, just like you can see the arrow pointing to the left up here. To the right of 2, use g of x equals 7 minus x. And that's all there is to it. Evaluating a function, but this tells you which side of a particular number to use for the evaluation. Let's do it again. Okay, here we have 3 parts, but let's put it in words. See how that goes to the left? For all the x's to the left of -4, or I should say, use h of x equals -3x minus 8 see, for all x's. Or values, that makes more sense. For values, which is the same as numbers. For values to the left of -4. Now, use h of x equals 4 not 4x, but just the number 4. Use h of x equals 4 for values between -4 and 4. And for x equals -4. I needed to write that in a different color. I'm not going to do it now. Guess I'll make them all blue. Okay, use h of x equals x plus 9. For all values to the right of 4, it's +4, including x equals 4. There. So now we have to know where these numbers are. We have to find -4, and we have to find +4. And here they are again, -4 and 4. So a lot is going to depend on the numbers I find. Let's start at -7. Let's let -7 be here. -7, make this bigger. Okay, -7, -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4. How far are we going to go? To 6. Okay. 5, 6. Oh, and let's put a 7 in there just to kind of give us a context. And we'll put a -8 out here. Now, the numbers that are of particular interest, the numbers where our changes occur are -4 and 4. So I am going to use blue and just put a circle around -4, excuse me, and 4. And make a dashed line. And make a dashed line. Okay. Now, we are, this graph is going to be broken up in this way. H of x equals -3x minus 8. H of x equals 4 for all of these x's in between -4 and 4, and for -4, because it says so. And over to the right of 4, we're going to have h of x equals x plus 9, and this also applies to the number 4. There. So, now what are they wanting? H of -7, H of -1, H of 4, and H equals -6, +6. And I need to uncircle -4 because they're not asking for H of -4. Okay. All right, well, so you look and you see on which side of the important numbers, -4 and 4, these numbers are. All right, we're being asked to find. It's H, right? Yeah, H. We're being asked to find h of negative 7, h of negative 1, h of 4, and h of 6. Okay. So, negative 7 is definitely in this area. So h of negative 7 equals negative 3 times negative 7 minus 8. So negative 3 times negative 7 is positive 21 minus 8. So that's going to be 13. H of x equals 13. Well, no, that's not the right way to say it. H of negative 7 equals 13. What that means is if x equals negative 7, y equals 13. And so your point, if you were graphing, would be negative 7, 13. Okay. Now in here, x equals negative 1. Whoop, let me write it down, 13. At x equals negative 1, well, that's going to go in here. H of negative 1 is going to equal, and there is no x over here for me to put the negative 1 in. So, h of negative 1 equals 4. And that would be true for all of these numbers, including if they had asked for negative 4. Negative 3, negative 2, negative 1, 0, 1, 2, 3. You would get h of x equals 4, 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 h of x equals 4. That's what you would get. Now, for h of positive 4, we were told that x can equal positive 4 for that part of the function. So h of 4 equals 4 plus 9 equals 13. And h of 6 equals 6 plus 9 equals 15. This ends up being pretty easy, much easier than it looks, because this looks really scary until you get used to it. But if you follow this approach, you'll be able to get these questions right.